Exercise 5 in SolidWorks 2016. In this exercise, we're going to take a look at the assemblies functionality inside SolidWorks. We're going to construct a bottom-up assembly. Bottom-up basically is taking parts that are pre-existing. They were designed previously, and it's essentially from a library, and you're bringing them in and you're mating them, adding common elements of geometry to the surfaces and edges to connect them. So let's begin. As you can see here, this is our goal, is to create this, it's somewhat of a widget. So let's begin. The exercise starts on page 58. The part files you'll locate on the vertanu1.com webpage, and then you're just going to go to the part files and find the exercise 5 parts. Go ahead and click on that. And the lab 5 part B parts are there as well. So later on, you click on that. So with this, it's in a zip file. So you're going to go ahead and open with, and we could just we could download this. Alright, up in the upper right hand corner, don't bother using the zip extractor, just go to download, and we'll use Windows to take care of that for us. Now once it comes up down in the lower left corner, I'm using Chrome, you could go ahead and hit the little arrow to the right of it, and you could go ahead and show in folder. And so once you have that, just find it and double click on it. Now you could shift select these or Control A and basically copy and paste those to another area. So I'm going to right click, I'm going to cut those out of there, and I'm going to go ahead and I'm going to go to I'm going to create a new folder on the desktop and just paste them there. So you could just right click, new folder, and I'm going to go ahead and just click on that, name it E5, and then double click and paste. Okay, once you have those files, now we could go back to SolidWorks. And you could go to File, New, and select Assembly and hit OK. Now go ahead and go to Browse and find that folder, the E5, and you'll see all the parts. If you'd like, you could actually go up here and make them larger so you can see what they actually look like. And in this case, what you're looking for is the sheet metal bracket. Go ahead and open that up and just click on the upper left checkbox to drop it in. By doing that, that little green check essentially drops the origin of the part file into the origin of the assembly, and that matches the two. So it's a very useful tool if that's the case with them. But not every part you're going to want to do that with, just remember. So now you'll see that the sheet metal part is fixed. If you right click, you'll see the float option if you wanted to break it away from the origin. But right now the little F in parentheses in the feature tree indicates that it's fixed. Okay, let's bring in the next part. I'm going to go back to Insert Components, Browse, and I'm going to find the yoke mail. I'm going to open that up and just click out here to drop it somewhere. Now, what we do is we use the little mate tool up here, the little paper clip that you see. Click on that. Select this pink surface, and right here, find this surface right here and click. It will automatically align the two. And what it did, it picked the most obvious of the options that you see here. There's parallelism, perpendicular, tangent, and there's concentric, which it automatically picked for us. There's many others as well. Go ahead and hit the green check mark. Over here on the left, you could hit the green check mark as well. Let's go ahead and see what we did. Go ahead and grab it and drag it, and you'll see you could rotate it, and you could drag it up and down. Go ahead and drag it down here a bit. Now let's take a look. Over here there's also the move component. If you click on that, you'll see there's standard drag, there's collision detection, and physical dynamics. Collision detection enables you to select an object and select all components or specific components. And as you drag it, when it hits, you'll actually see it will illuminate where it's striking and where the impact takes place. The dynamic clearance enables you to check the clearance between the two parts and hit resume drag, and as you drag it away you'll see the clearance. And you see the little dimension there. So it basically gives you the closest space. Alright, and then also you have the ability to go in here and set it to, you want it to stay within a boundary condition of some sort. You could put in a dimension, but since I have it partially constrained already, I'm not going to bother with that. Physical dynamics is a little bit more advanced. It's great for example, let's say you have a pool table and you have balls on the pool table. You could click on one of the balls and push it or move it, and the balls in its way will move out of the way. Actually, it will push them. But be aware it does not have like moments of inertia or things like that, or gravity. Those factors are not included. It just simply pushes items out of the way. All right, now the next thing we're going to do, we're going to go back to Insert Components, Browse, and let's find the next part here, which is the spider hinge. Open that up, click over here to drop it. Now, one thing I forgot to do here is I meant to mate this surface here to the underside. So before I mate that other part, go to the Mate tool, click on this surface right here, rotate it, and click on this surface up here to connect the two. Hit the green check mark to apply it. Now you'll see we have the blue surfaces here. We want blue to blue, and unfortunately the holes didn't turn out the way I wanted them to, so ignore the colors on the holes to some extent. But this blue surface, we could go ahead and mate it to this blue surface right here. And in this case it went coincident. Hit the green check mark. Now it doesn't look all that coincident, but if you rotate it and you'll see the orientation, or if you orient it in a certain way, you'll see that it is in fact actually centered and they're just a distance away. So the next thing we need to do is go ahead and select this blue hole that's attached to a blue face and select this hole here. Notice I'm selecting the actual faces. To individually select faces, you could right click and there's a selection filter option that you could select from right here. If you click on selection filter in the lower left, you could say I only want to filter faces, and notice the X key is the fast key for that, but there's all different types of filters. We just want filter faces. That way it will only allow us to select faces, but be aware you can mate planes, faces, as well as edges. Go ahead and hit the green check mark. And if we click and drag this, you'll see it now rotates only in certain areas. So essentially we've removed some degrees of freedom with those parts. You don't always want to remove all the degrees of freedom. In this case we want to simulate some sort of motion, so we're leaving some alone. Okay, the next thing we're going to do is we're going to go to Insert Components and Browse. And this one we're going to go ahead and find the yoke female. Go ahead and drop that right over here. Now go to the Mate tool, go ahead and you could select the red hole, and notice this hole's blue over here but it has a red face attached to it. Go ahead and select that open hole there. Hit the green check mark. Now go ahead and select this red flat face on the inside of the leg, but don't select this red face that's closest to it because it will remain in the outside. There is a flip switch, but sometimes depending upon what you have going on, it might not be the best option. So just select the opposite face, thus it moves the part in alignment the way we'd really wanted it to. Okay, finally you'll see this green, pale green face under here. Go ahead and select that face, and then go ahead and select this face. And it should align itself, and notice what it picked. It picked parallel for us. Hit the green check mark. Okay, another thing you can do is you could actually use your Explorer as a selection area. So here I have Explorer up, and I have all the pins and things like that. And all I'm going to do is I'm going to enlarge them so I can see images. So in the lower right corner here I could click and I could see the images, and I could stretch that out a bit. If you have dual screens, it's wonderful, because then you're able to actually have it up and you just drag and drop from one screen to the other. On here I'm just going to move this over so you can see both just briefly, so you can see how this works. So I have my library, and it's just a matter of grabbing things and dragging them over. So I'm going to go over here, and let's say we wanted to add the red pin. I'm going to drag the red pin in over here, okay, and just drag it floating out there in space. Now you could go ahead and go to the mate tool, click on the shaft of the red pin and the red hole, hit the green check mark. Now select this outermost face and select this black surface, or this dark gray surface where you want it to mate to. Notice it automatically picked tangency. Hit the green check mark to apply. Let's go ahead and drag in a blue pin. Oh, first you have to cancel out of the mate or hit apply. Once the mate is shut down, you could go ahead and drag in the next one. You could even drag in a second one on the opposite side. Now you could also do this. If you hold the Alt key down while you do this, and your mouse button, the left mouse button, drag that surface, grab that surface of the shaft of the blue pin and drag it to the blue hole. Release the mouse button first, then you could release the Alt key and hit the green check mark. Now you could go ahead and select this end face, go to the quick launch mate, and select this face here for tangency. Let's go ahead and try that again. Go ahead and hit the green check mark at the top of mate. Let's rotate this over here. And again, the Alt key, grab that face, drag it to the blue hole, and release it once you see it align. You see those little symbols to the right of my pointer, two concentric things. Go ahead and release at that point. Hit the green check. Now go ahead and select this end face, go to mate, and select this surface here to mate it to. Alright, there's also fasteners, and I'm only going to do one of these just as an example. Make sure, oops, I did it again. Make sure you hit the green check mark. Now you could grab the fastener and drag it in closest to whichever hole you want. Now go over to the move component and rotate component. You'll notice you could grab onto this, and what we're looking for is we want the socket to be exposed. So we want the socket sticking out on the underside there. Hit the green check mark. And now we could go and use our mate. So go to the mate tool, select the thread, and then select the hole. Hit the green check, and now rotate it if you need to. So you can select the end face where the socket is to this face here to make it coincident. And just go through and repeat that 3 times. It's good practice. Okay, now we want to go ahead and put the handle on. And by the way, if you grab this right now, it should rotate. If you grab it on the head or anywhere on it and move in small circular movement with your pointer, you'll see you could simulate motion. Get it to where that flat face is facing forward. And now let's go to the handle. Now be careful, there's a handle top and a handle section here. Those are individual parts. We want the assembly. Notice when we drag in the assembly, it turns into a sub-assembly in the feature tree. See the difference in the blocks? These are all individual. That's a blue block with the white, gray block, or whatever color it is. So indicating more than one part. In fact, if you hit the little arrow to the left of it, you'll see there's the handle and the handle top. Both components. All right, let's mate this. So I'm going to drag this over here. I'm going to go ahead and mate the outside surface to this pink surface, or I could have done the pink surface to the pink. That's fine. Now the yellow flat face, do not select the radial face, the yellow flat face right there. You're going to mate that to the yellow flat face right over here. Be careful, don't get the radius, or else it's going to screw things up. Hit the green check mark. And finally, this green ring, mate that to the top surface of the bracket. Now before you hit the apply, go to this option, the distance option. There you could actually type in a value. So in this case, let's say we want it's 0.01 inches offset. So just we're putting a little bit of a tolerance between the two. You could apply that, and thus you have a little offset. If you rotate and zoom in there, you can see it's not quite touching. So be aware you could add distance mates as well. And finally, hit your space bar and go to isometric. And let's test this out. Grab this handle and drag it around, and if it all moves together, you did it correctly. If not, go back, try it again. Also, the mates, if you ever do need to update a mate or change it, this little arrow here, if you hit that little arrow, contains all the mates, and you'll see it lists the parts. There's also another way, and you could edit these. You could right-click on it and edit the actual feature. It takes you back to those faces. You can select different faces. Sometimes I'd recommend maybe just deleting it. It gets a little confusing sometimes. I know this for my students, but needless to say, you could edit these. You could change the constraint, things like that. Also, there's another neat little option up at the top here. You could actually, under annotations, you have the ability to let's see here, enable the I will go back to that. But basically, there's an option where you could actually show the mates to each one of the parts. All right, let's move on. Now let's work on the lab. So just make sure you save that. That is saved as E5 in assembly. Be aware, try and save it in the E5 folder. Keep them together. If you don't keep them together and you end up moving them through Windows Explorer, you might find they detach, because these parts are required. All those parts that you see over here are required to be located by SolidWorks. In the first place it looks is the folder it's in. The second place it looks is the tag that actually is internal on the parts, and goes back, or references, I should say, the assembly tells it where those parts should be. If those parts are no longer there, then it's going to get lost and it's going to ask you to browse for them. So just be careful when you are sending this assembly. Send it as a group. Alright, also you could go ahead and turn off your selection filters. Hit this little button here, turn off the selection filter. It can be a little bit annoying from time to time. Okay, now the next thing is actually the assembly that's available here. So if you go to Part Files, the Lab 5B, go ahead and click on Download. And now over here, once it comes up, taking a little time here. My internet seems to be a little slow today. I just hit the little arrow and show in folder, and we could do the same thing. I could go ahead and just double click on that and shift select all those files, or control select them, right click, cut, right click on the E5 folder, and actually create a new subfolder in there. And that new folder, you could click on this twice very slowly, call it E5 or L5, and we'll call it B. Double click on it, and then right click to paste all of those parts in there. Okay, now we'll start a new assembly. And again, we could use this tool here to see all the parts. Just click on that little picture there, and let's first bring in the rear bezel. You could drag it in pretty much anywhere. You can eventually find the center of the screen. That's snapping it to the origin. It's kind of hard to find that way. Otherwise, you could go to Browse and hit the green check mark. It automatically drops into the origin. Now, a lot of these parts were built off of the origin, so technically you could just bring them in through Browse and hit the green check mark, and they're all going to assemble. But I don't want you to do it that way. I want you to bring them in individually and master how to mate this. This is a fun exercise, so give it a shot. So I'm going to drag this in up, hit the green check mark there. Okay, now for this first part, the circuit board, we want to mate up to these holes. Now just be careful, because some of these holes are a little bit confusing. Now this one's pretty easy. I could just select this face to this face here. Okay. Now the underside face, just rotate around so you can see underside, and then rotate it around and select that ledge right here for it to rest on. Okay, now we need to mate up this hole here, because you'll notice it's not quite mated up. Be careful, there's two holes. You want this hole here. That's for the light pipe over here. That's later. Click on this surface to this surface to mate those up. Hit the green check mark. Moving along, go ahead and now you could select the battery shield, drag that in, get that near that little rubber grommet, looks like an offset, and just go ahead and mate that up concentric to the outside. So select this face to this face, and then the underside face to this black surface right here. Hit the green check. Now let's bring in the battery cell. Oops, again, just hit the green check mark there. Let's drag that in again. Okay, now you're going to make one of these, and then we're going to pattern it. And we haven't learned about pattern, but we'll do that right now. So I'm going to select that face there, mate it to this face, and then mate the concentric edge or face here to this face here. Now I'm going to show you linear component patterns. Go up to linear component patterns, select it, select this edge right here for direction. See the arrow is pointing down, click it so it points up. Now the component to pattern, go ahead and select the battery, and I believe it's 60 thousandths distance, 0.06, because it's the thickness of the battery, and that's what it is. Okay, and just plug in a stack of 4. Bump it up to 4, hit the green check mark. Okay, now at this point, we're going to go ahead and select the connector, drag that in over there, and do the same thing, just attach it. So you could go concentric to the batteries or to this face here, hit the green check, and then we could do this edge. I don't want that edge actually. Let's just drag this up. We'll get this face to the underside face. And there's that little key there that's going to fit in the keyway in the top part. But let's bring in the light frame. Grab the light frame. Okay, and now with the light frame, again, go to mate. You could, to select transparent objects, you hold shift. Then you could select it. And select that, and then that post attaches to this. So we could go ahead and align that concentric to that. Hit the green check. And let's grab that and drag it out a bit. Okay, get the next one to align. That's this face here. Remember, shift will allow you to select transparent objects when there's something behind it. Make it concentric to that face. And then this edge here, again, hold shift if you can't get it. Select that edge to this green face of the circuit board. Hit the green check mark. And finally, let's bring in our front bezel. Now you could actually bring in your front bezel done in the last week's exercise if you want. And in this case, I'm going to go ahead and bring it in as defaults. Here, the details have all the extra details, and it was for photorealistic rendering. I'm going to go ahead and hit mate, and I can mate this face to this, make those concentric, and then just drag this up. We could mate this face to this face here. Again, it goes concentric. And finally, this face to this face. And let's put a little space in there. Go to distance, and we'll put in a small distance gap of 0.01. Hit the green check. Now to explode it, or first of all, you could go to section right here. And you can see a cross section. You could actually drag this through. See internally. You could change the directions. So you could section through and see what it looks like. To explode, go to exploded view, select this face, and grab the manipulator handle in the direction that you want to move it. So in this case, Z. Go ahead and click on this one now. Drag the manipulator handle. I'm clicking on it. And essentially just go through and you just keep doing this with the different parts, and you could spread them out. And there you can see they're exploded. Now if you ever need to edit the exploded steps, they're right here in the configuration manager, and you hit the little arrow and you'll see the exploded steps. You can just double click on the one you want to edit. Alright, to collapse it, go back to the feature tree here, and at the top where it says the assembly, right click, and you'll see two options, animate collapse or collapse. If you choose to animate the collapse, you could see it animated and even save it here as a certain type of file. So you could post it on YouTube or whatever you want. And that concludes exercise 5.